Hi, everyone. I'm Amir from Personi Labs. And today I'm going to give a quick presentation about ZK-enabled digital identity. So just to give like a quick outline for what this talk is going to look like, it's going to start off a little fuzzy, maybe a little thought leadership-y, but we'll slowly become more concrete over time. So kind of talk about what we think the future of identity looks like, and then what work has already been done in the space and what are some future directions that we think are pretty exciting. So I think a lot of the motivation for this like work of ZK identity comes from this like overarching question of like how will we express ourselves in the future? And we think like every time like as technologies evolve, kind of the way we've done that has shifted and changed over time. So when computers first came out, we had like these like anonymous group chat messages and like anonymous uh, Reddit forums and stuff like that. The way people started to engage with each other kind of changed. That was kind of like a step function change in the way people interacted online. And the claim kind of behind all of the CK identity stuff is we think we're on the verge of a paradigm shift in the way we express ourselves online. And we think ZK is going to be like a very big kind of motivation and source for that. Um, and so we think this is kind of like this claim is basically like backed up in two trends. So the first is this idea of like publicly verifiable social networks. So like until about like a couple of years ago, like all the social networks that we've used and like we've interacted with, like Twitter, Facebook, etc., we couldn't make these like verifiable claims about stuff that has happened, right? Me tweeting something or me posting something on Facebook I could not do it in a way that basically like that could be verified against kind of this history of like cryptography and like contain this like nuanced set of statements associated with it. And so we think with like the emergence of networks like Ethereum, like this kind of changes the game with what we can do and like the types of statements we can make and the type of like rich information this brings. And this is all done in a way, obviously, that like we can verify it in a way that like previously could never have been done before. The second one is this kind of notion of like powerful consumer available cryptography. So we think that like ZK is like gotten significantly better over the past couple of years and has gotten good enough that like we can run it on like consumer grade hardware. We can run it on our phones. We can run it on our laptops. And the like kind of overarching thing behind this is for the first time, like we've traditionally like operated within the bounds of cryptography and we've been able to like make kind of claims and statements about what cryptography is allowed to do. So like we've had signatures for a long time and like given a signature, like we can make a claim that I own like a private key that like corresponds to some public key, right? And now with ZK, we have this notion of like programmable cryptography. Like now you can roll your own crypto. You don't have to like, uh, you're not confined to making the like specific statements that each primitive brings. Now you can like basically say, oh, I like know like a private key that corresponds to like one of these and public keys that satisfy this predicate. And so for the first time, we now can effectively like roll our own cryptography. And we think this is going to bring a really rich set of like predicates that people will engage with and people can like take advantage of on the application level that haven't been possible before. And kind of like what's the point of all of this, right? I think one framing I really like with all of the ZK identity stuff is thinking of like identity as this like new set of rich characters that it will create. And so like traditionally in the past, like talking to people, like we've always like the way we talk with different people in different settings changes. And we think the internet has like brought this like explosion of like what we would like to call like new character creation, like people basically playing these different roles in these different settings in ways that like the mediums provide for them. So me posting something on Twitter versus me like anonymously like commenting on some like forum on Reddit, we think all of these are like very different. And we think like all of this like ZK stuff is pretty important and like these new sets of characters that they will unlock. What's been the journey so far? So that was kind of the thought leadership part of the presentation. So looking back at like where we started and like where are we today. So kind of the roots of like this idea of like ZK identity, we think started or like began a while ago, but like one of the kind of first important points was some of the primitives that came out of the 0xPARC learning group, the first learning group, and um, one of these primitives was basically this idea of like doing ECDSA operations inside of a snark. So before this learning group, kind of like there was this notion of like maybe there's something special that we can do with these ZK statements, but like we can't associate them with like like Ethereum public keys or whatever, like what's the point, right? Like we operate in a 254-bit field and like CirCom and all these other languages, like maybe this isn't possible. And then a bunch of people were like, actually, no, like we can do something here. And so this was kind of they like work actually a lot of people in this room and 0xPARC more broadly kind of works on this project of like basically putting these ECDSA operations inside of a snark. And what it then allowed us to do was be able to make anonymous statements about your Ethereum address. And so for the first time, we could like couple these kind of like statements or claims and very closely like tie them to like basically like Ethereum, the world of like Ethereum and crypto land. And so one of the first things that was built with this was this thing called Proof of Planet, which was basically a way that allowed people to create new identities by making nuanced statements about your Ethereum state. So if you were a Dark Forest Planet owner, you could go and you could mint this NFT, and you could mint this NFT by like basically giving this like ZK proof that you were part of these like subset of people using this primitive. Like when this like project first came out, a lot of this stuff was on chain, and we were just like still figuring out like user behavior of like what will it look like, what makes sense with all these primitives. And basically the like lesson was like, okay, on-chain verification is expensive. Maybe not everything needs to be on-chain. Maybe we can like just verify this in the UI and like we can provide ways for people to convince themselves when they need to that like these proofs are valid. And then this will trigger like this behavior that we want to generate as a result of this proof. And basically this was the like one of the first like application level work that took advantage of this primitive. And it like started to carve out these like set of techniques that have made their way into like the ZK identity space. And like one of the first kind of techniques that arose was this idea of like set membership. And like at its core, it's like pretty straightforward and pretty simple. But all of the different ways that you can use it like unlocks like a whole range of possible applications. And so the construction is like really simple. It's like, hey, let's create this Merkle tree where like all of the leaves correspond to something. So maybe all of the leaves correspond to like Ethereum addresses or Ethereum public keys. And you like generate this proof that you are like a member of this group without revealing which member you are. So these constructions existed before in like things like ring signatures and group signatures, but this was kind of the like the start of like these primitives like slowly making their way into like ZK land, where they then kind of get built on top of them and like be made like kind of much richer. And so one of the like applications that like emerged taking advantage of this property or this primitive was this project called Hanon, which spun out of also the 0xPARC summer residency this summer. And the like basically general idea was it was membership based anonymous tweets. So this took several different flavors. And I think it's like worth looking at like each different flavor. So when Hanon first launched, they launched with basically with fixed groups. So what that means is basically they like generated a group about some interesting thing that's happened on chain. So like take for example the DAO hack in 2016, right? They generated this like Merkle tree of like all the set of addresses that were like victims of the DAO hack in 2016. So it was these like static groups that people could be part of. And by like having an Ethereum like public key that like interacted with this specific group, you were like automatically part of this group and you could now make these anonymous statements. And so like one of the groups that they made was all like members of people who had like donated in Gitcoin round 13. And one of the interesting, if you look at the top left, comments that emerged from this was basically like someone like talking about or like asking about this project. So Acne was one of like CirCom's like a project that like was trying to formally verify circuits in CirCom. And the tweet was like, oh, like, is this a failure of like the structure of Gitcoin that this only received X amount of funding? So maybe something that people would like traditionally like feel less comfortable sharing if they didn't have this idea of like a credible pseudo anonymity behind it. So that was kind of the first flavor. It was these like prefix groups of like interesting things happening on chain. Like let's like make a group for it and let's allow people to make these like verifiable statements that they were part of this group without revealing themselves. The second interesting flavor that Hanon kind of took was actually at a lot of in-person conferences. So if you guys were at SBC, one really interesting experiment that they played with was like, what if we allow people to, what if we like could provide some of these like credible pseudonymous guarantees, but like try to like bridge it into the real world. And so what they did was like when you would like enter the workshop, they would hand out these QR codes. And by scanning the QR code, basically you could like post or like tweet something associated with like the type of person you were or the type of like the type of affiliation that you came. So whether you were an attendee or like whether you were giving a presentation or whether you come here before. And so if you look at the bottom left, that's basically what like the suite was. You would scan in, you would like, you'd come in, you'd scan your QR code, and then you could like basically pseudonymously post and like attach this like verifiable proof that people could convince themselves of. The third flavor of like HeyAnon that emerged was, what if we started playing around with the social dynamics of what the stuff entails? And so there's a lot of language in like ZK of like proofs and like of verifiers, and a lot of this stuff is like kind of like intimidating for people who aren't in the space. And so what they did was basically like create these like magic like rules that people could engage in. And they like were playing around with the linguistics that people could use in order to like engage with this. So instead of like generating a proof, you would be casting a spell. Instead of being like a speaker, you were a sorcerer. And so it was like maybe one of the first kind of like almost like Harry Potter games powered by cryptography, like in real life. And so this is kind of like when we bring up the idea of like character creation, we think this is like the type of like very cool dynamics that this will enable, which like previously have been possible. And it's like, okay, what kind of new characters can create? What kind of new like interactions and new dynamics can this power? Um, and so the kind of like second technique that emerged as a result of this, which was like semi-related, is this idea of semaphore, which is effectively set membership. So proving that you are like part of some group without revealing who you are, with this added thing of signaling, which is like, let's say you want to like prove that you are part of some membership of some group, and you want to like, but you only want to be able to do it once. And so you want to signal that you are part of this group, and this active signaling now basically like removes you from being able to do it at some point in the future. And so basically the construction changes where instead of each leaf being, let's say, your Ethereum address or your public key, it's now this Pearson hash of your public key and this like nullifier and this trapdoor. And this nullifier, the intuition for the nullifier is like something that like you keep track of in order to prevent double spends. So if any of you guys have like looked into Tornado Cash or other similar like schemes, the notion is basically like you want to prove membership, but you also want to be able to signal without double spending. And that's kind of the point of the nullifier. And so this is like basically like if you the act of signaling basically boils down to like checking that you are part of this group and then checking that like the nullifier has not already been used. And so like this primitive was taken and like was applied in like various other ways. So HeyAnon was like a flavor of this basically without the signaling. Another project that kind of came out of some of these like new identity experiments was project called ZKPin, which is like called trust minimized commitment pools with ZK snarks. So if you guys are familiar with commitment pools, Vitalik has talked about this idea before, but there's this notion of like you want to create some kind of pool that aggregates people's endorsements of something anonymously until some threshold is reached, past which it becomes public. So you can imagine for like the basically like intuition is like this idea of like power in numbers, which is like you want to endorse something, but you only feel comfortable doing it if enough other people do it. And it turns out that like ZK basically can like provide the tools for you to be able to do that. And so the construction is like, let's say you have a commitment pool. So like ZK is very underrated. And you have like different signers who want to endorse the statement. So they can go ahead and they can like anonymously sign that like they endorse the statement, and produce a proof that like attests to certain properties, that like the signature is valid and that they're like actually a real person. So they're in like some subset of like Sybil resistant people and so on and so forth. And if the number of signatures is greater than the threshold, then the operator can basically trigger a reveal, and then everyone who's signed can like be everyone whose signature was previously anonymous becomes public. And so like hence like this notion of like power in numbers or like only revealing past a threshold. And the reason this is like a cool construction is like basically for the first time you now have this like new coordination mechanism that's taking advantage of the properties of ZK, and like giving people like strong guarantees that like they can only like reveal their affiliation publicly once this threshold is reached. Another interesting project that and like new line of research that's been worked on by some folks at Personio and 0xPARC is this idea of deterministic nullifier schemes. And so the general intuition is like, okay, set membership gives us pseudo-anonymity, but what if we want unique pseudo-anonymity? And some early research from folks at 0xPARC and Geometry have worked on this ECDSA nullifier scheme that gives us these properties. So it's unique in the sense that like every Ethereum public key, you can like now map it to some unique deterministic nullifier. So in the semaphore construction, the way you generated these nullifiers was it was like basically kind of opt-in. So you would come in, you would like register in like whatever kind of like cryptography like key registration pipeline they have, and then the active registry generated this nullifier. And so the anonymity set was basically everyone who'd previously registered for it. And so this like new nullifier scheme is like non-interactive in the sense that like you don't have to basically go through this process. And the anonymity set is not like purely initially restricted to people who had previously signed up before, because it's deterministic from each key. And so hence basically it's like verifiable and it's non-interactive. You don't have to go through this process. Another interesting project that is like recently like launched at Dogsa is this project called Proof of Email. And what it is basically trustless email verification on chain. So the general construction is like basically ever since 2016, emails for the most part have like followed this like scheme of like you're trying to convince yourself of like, how did this email come from the person who claimed that it is? And so every email basically gets signed by the corresponding like mail server's key. And so what Proof of Email did was basically take this kind of like verification that like happens by most mail servers like, or in most email clients like Gmail, and put it inside of a snark. And so what you now get is you can basically verify an email, verify receipt of an email, or verify ownership of a particular domain address without revealing what your actual email address. And the construction this boils down to is basically like you're verifying the RSA signature of the hash of the from to field, the body hash, and then the key that like the key that this mail server is coming from. And this is like cool for a variety of reasons. But in order to make this possible, a bunch of like circuit innovations had to happen that previously did not exist. So one of them was dynamic length SHA-256 hashing. So previously in Circom, you could only do basically fixed length hashing. And the insight was like, if you like basically unbundled the way like SHA-256 works and all the different rounds, you could like come up with this like clever idea of like passing in the like n-1 like round so far, the hash of what you have so far, and then verify that inside of the snark. And so because of that, you can do dynamic length hashing. The second thing was Ayush and some pretty people who worked on the project basically put regex inside of a snark. So they put a DFA inside of a snark. And so you can now, in order to basically verify that like the structure of the email was correctly formatted. And so now you can basically do regex inside of a snark, which is like extremely cool. So like, yeah, but basically like what does this enable? You can now create proofs and make statements about Web2 claims trustlessly, or on chain. And I guess like the caveat here when we say trustless is like, you're trusting that like mail service and DNS protocols are operating correctly. But like, we think there are like sufficient checks and balances to like basically keep those parties honest, such that like, it's okay. Like that doesn't feel like too big of a trade-off. So like, what can you do with this? Like what cool stuff exists before, or like what cool stuff like can you build with this? So one demo that they basically gave was trustlessly proving ownership of a Twitter account. And so the flow was like, you would send yourself, I forgot my password email, or like reset my password in Twitter. You would download the like headers associated with that email. And then you would take them, you would paste them into this app. And like, you now basically have this proof that like you own this particular Twitter account, again, without having to dox your details. And now that you can do this, you can think of like, okay, what are all the types of interesting emails I get that we can now make statements about? And so like, if anyone has a bank account, like I'm sure like you guys know that like you probably get like a monthly email saying what your balance is. And so now you can basically like create this group that like trustlessly verifies that you have like greater than N amount of money in your bank account. Or like if you like want to verify association of basically any kind of like account, like any your like GitHub account or anything like that, you can basically follow the same pattern of being able to prove that. And like you now have this like succinct proof that is trustless, and you can now like bridge on chain and make claims about it, which is pretty cool. Because like for the longest time, like a lot of the interesting statements we could make in like the world of crypto were pretty siloed. Like what we can do on chain was mostly limited to like what exists on chain. And now with like some of these primitives, you can like basically like trustlessly verify certain statements and like bring them on chain and do what you want with them. Um, so that's kind of been like a very kind of short, incomplete subset of like what are like all the interesting projects that people have worked on. So like what are some interesting kind of future research directions we think are pretty fruitful. Um, I think the way we're thinking about it at Personi is like we think there's this like relationship between the idea of like building cooler apps and building better technology. And we think the both of them like go hand in hand. So we think like the reason like the reason there are a lot of these like cool identity experiments is like, okay, at face value, like some of them are pretty useful and maybe some of them are less useful, but we think they're like inherently extremely cool. And we think this idea of like pushing the boundaries of how we express ourselves and like what we can do online is going to inform better technology. And that's going to inform kind of future research directions of like, what are the current limitations where we need to do better? Like where are places that we can take advantage of the existing like primitives for? Um, and we think those like basically you have this like cyclical relationship of like, okay, now we've identified those things, we work on them, we like make progress in them. And now that's going to enable kind of cooler apps and like more useful apps that we think will become mainstream. So what does that look like concretely? So here are some examples. A proposal was passed a couple of weeks ago, actually, by Noun's DAO called Hey Noun, which is trying to basically create a platform for pseudonymous messaging about props for nouns. In a couple of weeks' time, there's going to be one of the first kind of like identity-wide experiments being used by like but by Nouns DAO, where people will be able to like pseudonymously post messages about props. We think that's going to basically like it's going to be very interesting to see the type of like the type of like interactions and like conversations that come as a result of this that were previously like not possible because of this like idea of verifiable pseudo identity. So the second one, like more concretely, is basically like more efficient signature schemes. So actually, some work by some folks at Personi have recently come up with this like more efficient ECDSA construction that is around like 3 times faster. So like the verifying an ECDSA signature in CirCom right now takes about like 1.5 million constraints. And some people have ported those over to Halo 2 and like they're still like in the process of benchmarking it. But they're like this basically this new construction like uh, cuts down the number of constraints by a third. And there are like a couple of like interesting insights that make it happen. But like the general idea is like you can like move some of the things that you're trying to verify inside of the snark outside of the snark with like a couple of like interesting math tricks. Um, the third one is interoperating with new types of signatures. So proof of email was like one of the first projects that basically looked at how do we take a existing signature scheme in a non-crypto land and be able to like generate like interesting statements about it, interesting verifiable statements. And it turns out there are like various other kind of signature schemes that exist in the wild that people can take advantage of. So like one example is like JWT tokens, which are used pretty heavily in like a lot of like verifying OAuth and like verifying like cookie sessions in general websites. Another is SXG, which is basically used by like Google to like determine like whether to like deliver a cached version of a website or like reload the basically bundle. And there are like these other like various signature schemes that exist in the wild. And it turns out that like we can now try to like make interesting statements about them by like putting them inside of a snark. And we think that's going to enable a lot of like interesting applications that connect Web 2 to crypto land, where previously they've been kind of siloed. Um, the other kind of thing is like formalizing this language of predicates. So like this idea of like set membership or like set membership with signaling, we think like it boils down to this idea of programmable cryptography. But what that really is like basically a language of predicates, which is like you have these different statements, you have these like conditions which are either true or false. And now you can do all kinds of interesting things. So like one example is like the way social media exists in its current form is like traditionally you have something like Twitter or Facebook and you have like one stream of like followers, people you're following, or like, and people who follow you, or like people you're friends with, and people who people who you're friends with, and people who are like you're not friends with. And when you post something, or when you like tweet something, or when you comment on something, traditionally like that is like going through one flow, or like one channel to the output. But it turns out that like, what if you basically could control like who that flow goes to? So like, what if you could, for example, make a tweet and like want to constrain it by like, the only people who can see it are people that satisfy this predicate. So like, I want to tweet out ZK is very cool, but I only want to do so if you've interacted with like XYZ contract, or if you like own this NFT, and various other kinds of complex predicates. So we think this is gonna like really change the way people interact online, and like kind of turn a lot of these like social like media platforms into much more rich and like much more nuanced ways that people are expressing themselves and people interacting with each other. And there's a whole other kind of like range of exciting work happening at Persony. So definitely be sure to check the Twitter out for like upcoming launches. Yeah, and that's it. Any questions? Like one primitive, or okay, yeah. Yeah, I think that like my intuition for it is that like there are these like primitives that exist for the types of statements we can make using snarks and like various other kinds of proving systems. And like it's unclear what types of applications are like actually going to become mainstream. Like what types of applications do people care about? And we think like, and I think like personally, they're like all these primitives are just like different tools in your toolbox. Just like until like 2 years ago, I think like when a lot of people were like, when ZK stuff was still very early, like there was a lot of attention on CirCom because that was the existing tool that people could use. And like now you have all these other different proving systems that come with different trade-offs. And like now it's like, oh, like what type of proving system should I use? The kind of range of possible options that you can take is much more complete. And I think like at least my model for it in my identity space is pretty similar, which is that like you have all these different primitives, you have like set membership, you have this like proof of email thing, you have like various kinds of like programmable ZK constructions. And I don't think one is necessarily more important than the other. The like at the end of the day, they're just going to be like all different kinds of tools in your toolbox. And the most important thing is like basically the business logic, which is like, what can I do with these tools? What kind of applications can we build to take advantage of these tools? And like ultimately, those will determine like what people want to use. And I think that's going to motivate basically future directions. Any other questions? Cool. Thank you.